All right, 50 office towers in the shape of that, blah, blah, blah. Okay, it's not drawn to scale. Okay, so, oops. So, calculate correct to three significant figures. The size of the angle between OF, and FG. Okay, so we want that angle. So, this is a square. So this is 6. And this is this is 10. So we're going to use cosine rule. So this is C, so we've got C here. So 10 squared, or we'll do cosine. Cosine of C equals 10 A squared plus B squared minus C squared over 2AB. So C ends up being 72.5 degrees, and we want the shortest distance, so this is going to be perpendicular. So we have Pythagoras, so 3 squared, because we're going to use this, plus x squared equals 10 squared. So x ends up being 9.54 meters. And we need the total surface area of the 4 triangular sections of the roof. So we've got 4 triangles. Each triangle is 1/2 base, which is 6, times the height, which is that 9.54 unrounded, which ends up being 114 meters squared. Now, the size of the angle between the slant height of the roof and the plane EFGH. So that's going to be this O, so this one, that's the slant height, and we want that with the plane, so that's this, if we just like that, it's that angle there, okay? So I'm not going to use that whole thing, I'm just going to use, obviously, half here. So it's a right triangle, and this bit is 3. We've got this slant height, which is the 9.54, and we want that angle, so that's cosine of that angle is the adjacent 3 over the hypotenuse, the unrounded 9.54. So that ends up being 71.7 degrees. The height of the tower from the base to O. So that's going to be 40 plus, now we need this height here. So we can use SOHCAHTOA or Pythagoras. I'll just use Pythagoras. 3 squared plus, I'll call that y squared equals x squared. So y ends up being 9.06. So this whole height of the tower is 49.06 meters. A parrot's nest is perched at point P on the edge BF of the tower. A person at point A, so this parrot nest is like here. Outside the building, measures the angle of elevation to point P to be 79. So this is with the horizontal 79. Find correct 3 significant figures. The height of the nest from the base of the tower. Okay, so maybe the parrot's nest is like here or something. Either way, it's angle of elevation 79. So basically, we'll say this is x, whatever the height of the parrot's nest is. So we've got opposite and adjacent. So we've got tangent 79 equals opposite x over adjacent 6. So the bird nest is 30.9 meters in the air. All right, 51 in the diagram below. The points O and A are fixed. The angle OPA varies as the point P moves along the horizontal line y equals 10. Show that AP is equal to that. So this is just the distance formula. So we've got the square root of the x's subtracted and squared plus the y's subtracted and squared. So that's x squared minus 16x plus 64 plus 16. So that's your x squared minus 16x plus 80. So for double I here, write down a similar expression for OP. So OP is going to be just x minus 0 squared, so x squared plus 10 minus 0 squared, which is 100. Hence show that cos OPA equals that. So that's cosine rule. So we're going to have cosine OPA equals O to A, which is, okay, so OA, we have to do that. So that's going to be 8 minus 0 squared plus 6 minus 0 squared. So that's 64 and 36 root 100, which is 10. So, okay, so we have, so that's C, and this is A and B. So we're going to have A squared, which is x squared plus 100, plus B squared, which is x squared minus 16x plus 80, minus C squared, which is 100, 10 squared, over 2 times root x squared plus 100, root x squared minus 16x plus 80. Okay, so yes, we have 2x squared minus 16x, the hundreds go away, plus 80 over all of that. We can bring them under the same square root. And then we can factor out a 2. So the 2's will cancel. So I have x squared minus 8x plus 40 over all of that. So now find and degrees the angle OPA when x equals 8. So cosine OPA. All right, so if x is 8, we've got 64 minus 64, so just 40, over square root of 8 squared plus 100 is 164, times, this is 8 squared, so 64. So this, when you substitute an 8, it gives 16. So if we have 164 times 16, that's 2624. And when we do the cosine inverse of that, you get that OPA is 38.7 degrees. So now find the positive value of x such that OPA is 60. So we're going to have cosine 60 equals all of this. Square root x squared plus 100. Okay. So cosine 60 is 1/2. And we'll cross multiply. Equals this. So if we multiply by 2 and square that, so we're going to have 2x squared minus 16x plus 80 squared. So they want the positive one, and when I put that in, I got negative. So just put after your x and your NSOLVE, comma, maybe 0, and it gives you the next up, which is 5.63. The other way to do it is just up here, put this in y1 and this in y2 and find the intersection. Okay, so for E, we have consider the equation f at x equals 1. Explain in terms of the position of the points OA and P why this equation has a solution. So if y equals 1, okay, so this is f at x, I missed that. So if we have 1 equals that, so we're going to have 1 equals cosine OPA. So we're thinking, when is cosine 1? Well, it's here at 0. So that means the angle OPA is 0. So OPA. So I think that means that P would have to be over here, I think, so that we would have an angle of 0, because it would go like O to P then to A, and angle P is 0. Yeah, so that's in terms of the position, they're all on the same line. And find the exact solution to this equation. So when we would do 1 equals x squared minus 8x plus 40 over square root of this. Okay. You get that x is 13.3. They give another, they want the exact solution. So yeah, you can just do, turn it to a fraction, 40 over 3. They give another solution in the answers. Okay. Last one. 52. The points P, Q, R are 3 markers on level ground joined by straight paths. So this is looking at it from above. Find the length of PR. So sine rule x over sine 35 equals 9 over sine 120, because the triangle has to add to 180. All right, Tom sets out to walk from Q to P at a steady speed. Okay, so first of all, this is 5.96. So steady speed of 8 kilometers per hour at the same time. So Q to P. Alan sets out to jog from R to P at a steady speed of A. They reach P at the same time. Calculate the value of A. So if I do W out sine 25 and find out what W is, W ends up being 4.39. Okay, so this is how many kilometers these paths are. Okay, so the 5.96 that Tom is walking. No, Tom is not walking that one. Tom is walking the 4.39. So we can think of it as 4.39 will take him how long if 8 kilometers takes him one hour, okay? So this will take him 0.549, hours. And for Alan, same thing. 5.96 will take him how long if A kilometers per 1 hour. So his time will be 5.96 over A, and we need to set these two equal to each other and solve. So when you divide 5.96 by the 0.549, you get that A is 10.9. So that's his speed. All right, C, the point S is on PQ such that RS, so if this is X, this is 2X. Find the length of QS. So this is 35, and this is 9. So we have cosine rule. So we're going to have 2x squared. No, we're not going to have 2x squared. We are going to have 9 squared plus x squared minus 2 times 9 times x cosine 35 equals 2x squared. So c squared equals a squared plus b squared minus 2ab cosine c. All right, so if we do this one out, 4x squared, and I think we can just use nsolve or graphing calculator. So here x is 3.29. Yeah, that's that.